I am the Chair and Executive Director of Computing and Data Science Programs at the university. What that really means is just that I'm in charge of the day-to-day for all of our computing and data science programs, both at the undergraduate and graduate level. And that involves wrangling faculty, which is like herding cats. But I love my faculty, so don't tell them I said that. Okay, so usually folks come into this type of presentation with at least a vague understanding of what data science is and why they might be interested in it. But I have my own take on the field, and I wanted to start by talking a bit about what a data scientist actually is. And so here's a definition that I found while perusing the internet for such things. I think it's reasonably good. And if you were to poll, a cross section of data scientists out in industry, I think the majority would agree with this sort of characterization. Basically, data scientists are a hybrid. So a bit of computer science, so some programming is sprinkled in there, the ability to manage data, and a statistician, so someone who can look at data and derive insights from that data. Those of us who are on the inside talk about data scientists tongue-in-cheek as a mediocre programmer combined with a mediocre statistician. And we say this jokingly and lovingly because the truth is the intersection of programming and statistics is a really, really valuable place to play at the current moment in time. What I think is missing from this definition is a focus on context. And so if you think about what data science is, certainly it's programming, which involves things like automating processes. It's definitely statistics, which involves things like running models, machine learning, artificial intelligence, and definitely managing data. But what loses out in definitions like the one I just showed you is the context. And really things like managing data, designing experiments, deriving insights, presenting findings, those activities constitute the vast majority of your time as a data scientist, and yet they have often only a little to do with the programming and statistics that you've learned, and a whole heck of a lot to do with the context within which you are operating. And so when we designed our program, and I'll get to the details on that in a little bit, we focused a bit more heavily on the context in this Venn diagram. Why data science? Well, you probably have your own reasons for being here, but there are many more, I can assure you. Number one most promising job, according to LinkedIn, it has been topping the list of Glassdoor's best jobs for the past 3 years. Median salary of 130,000. I think last I looked, the average starting salary for data scientists in the Portland area was around 120,000. Now, that isn't everyone out there, and often those who are much earlier in their career don't quite crack that level of salary, but it is a great indicator of where the industry's at and where it is going. There are a couple of hidden reasons as well. You might not think about it, but the truth is that coding, statistics, all of the things involved in data science are really important even if you aren't a data scientist. So 50% of the jobs in the top income quartile, meaning basically the top 25% of salaried positions, require some form of coding. And we know from kind of tracking this sort of thing at the undergraduate level that taking courses in these areas generally doubles applicants' jobs prospects and increases their starting salary from between somewhere at 15 and 20,000 compared with their peers. And this last statistic is one that just blows my mind every time I see it. But there are more open positions in computing and data science than all of the filled positions in every other STEM field combined. That basically means that there are more unfilled positions, job openings right now in computing and data science than there are people working in every other STEM field combined. This is a crazy statistic to me and something that really illustrates the level of demand that we're seeing for this kind of work. How do you data science? So if you look on LinkedIn and you kind of look for their skills tracker, the most requested skills for these types of jobs, so if you just kind of collect them across the range of LinkedIn job openings, you'll see that R and Python top the list. So these are scripting languages, so programming languages that you need a working familiarity with in order to do this kind of work. Data engineering, and what this really means is a familiarity with SQL, or structured query language, which is a scripting language for accessing data stored in databases. In addition, data engineering covers things like data management, enterprise data management, data lakes, data streaming, a variety of other data management techniques that are in vogue at the moment in industry. And then third, machine learning, which is essentially the statistical modeling portion of the data scientist's job. Hidden deep in these job descriptions and surfaced in most conversations that I have with industry professionals is this fourth skill, communication. If you want to get ahead in a field like this, it's not enough just to know the programming languages and the statistics. You also have to be able to translate what those skills into something that helps people make decisions. And so this is, these are things like data visualization, writing, believe it or not, presentation skills, and general communication in an organizational setting. And our program focuses on all four of these. So here are the basics. It is a 12-month program that is comprised of 9 separate classes. The required classes within the program are Foundations of Data Science with R, Data Visualization and Presentation, a Data Engineering course, Data Ethics. We are the only program of this type to actually require ethics in the curriculum, which I think is a strength and a differentiator of ours. Applied Machine Learning, and then finally the capstone seminar. And roughly speaking, there are 3 electives that you're able to select from. Not all electives are offered every semester. Typically, students will select an elective in their first semester and then 2 electives in their 3rd semester. If you just want a taste of data science and not the whole thing, We also have an option to enroll in the certificate version of this program, which is made up of the first 4 courses in the core. Here's an example curriculum for the typical student. In fall, you might take foundations, data visualization, and marketing analytics. In the spring, data engineering, ethics, and machine learning. And then in the summer, a couple of electives like natural language processing and Python, along with the capstone seminar. I typically teach the capstone seminar, and we focus on things like interviews, networking with industry professionals, and developing a real-world project that you get to add to your portfolio, getting you job ready. We have other career readiness activities as well. In the fall, we have our main career fair, and this includes both the graduating class of master's students and the incoming class of master's students. And so it serves as a venue where not only do you get to interact with the employers that are looking for folks like you in industry, but also you get to network and learn from the recently graduated folks to form your network of individuals, which we all know is very important in developing a long-term successful career. In the spring, we initiate individual advising, where you actually meet with our dedicated career advisor. They will help you do all of the things that you need to do to make sure your resume is polished up, that your skills are ready, etc. And then in the summer, we have a series of activities that are connected to the capstone class, including practice interviews, various opportunities to present your work in front of industry professionals, and of course, developing a portfolio piece that you can then take to these interviews in order to get that dream job. A couple of notes: the majority of our graduates have jobs within 3 months of graduation. And last year, our average starting salary for the cohort was $113,000. Very good students last year. Details: I think I covered this, but 9 classes over 3 semesters, fall, spring, and summer. And so you can complete the entire master's in 12 months, although some choose to take a little bit longer, taking only 1 or 2 classes throughout the year, and then complete the master's over 2 years. Tuition is $1,200 or around $1,300 per credit, or $46,500 in total for the entire degree. Classes are held in the evenings at one of our 2 Portland campuses. And so typically classes are Tuesday, Wednesday, and Thursday evenings from either 6 to 9:30 or 7 to 10 p.m., depending on whether it's a 14 or a 15-week class. In terms of financial support, if you happen to be a Willamette student or alumni, you get an automatic 20% tuition discount. There are, of course, both federal and private loans. This is an accredited program recognized by the federal government. And then the vast majority of students also get some form of merit scholarship. And so upon application, all students are automatically considered for merit scholarships. Typical awards are in the $5,000 to $15,000 range for these merit scholarships. The application process involves submitting a resume, your transcript, a short essay explaining why you actually want to pursue this kind of degree, and then very importantly, 2 letters of recommendation. We take these letters of recommendation very seriously, and so choose folks that can give us a good representation of your ability to succeed in a program like this. We do not require any GRE or GMAT score in order to apply for the program, trying to reduce hurdles to application here. But some programming and statistics experience are recommended. If you don't have any programming or statistics experience, that's okay. We are mostly looking for folks that are driven and committed. The one feature that is most important to us is persistence. Those who have gone through programs like this and who do this kind of work professionally understand that it's a process of lifelong learning. And you need to be self-motivated, and you need to be willing to try and fail and try and fail and try again until you finally get it right. And so that sort of grit and persistence is the #1 characteristic of successful data scientists. And we look for hints of that in your application. Last but not least, early application deadline is January 10th. If you want to be considered for the maximum merit scholarship, you need to get your application in by this deadline. And that's all I have. So I am ready for questions, Hillary.
Great, thank you, Jameson. Can you tell us any more about kind of industry contacts or what kinds of industry folks are recruiting, you know, in terms of our past classes or what we're seeing? Is everyone staying in Portland, or are they getting jobs around the country?
We have a large draw from both San Francisco and Seattle, as you might imagine. Those are both tech centers, and there are a lot of jobs in both places. However, for those who want to stay in Portland, there are ample positions in Portland. We have folks from Tillamook Creamery, Kaiser, Intel, Nike, Daimler, Adidas, Under Armour, not to mention the state government, all hiring in the data science and data analytics field in our area. And many of our students have been placed in these types of companies. One of our students was the very first data scientist ever hired by a district attorney here in the state of Oregon, which was really fun. We have another recent graduate who is a Portland public school teacher and went back and used data science skills to kind of elevate graduation rates in the Portland Public School District. Colleagues of mine are using data science to help understand salmon migration in the Columbia River, place children successfully into foster care, and of course, sell shoes for Nike, because it wouldn't be data science without a little bit of shoe peddling.
Excellent, thank you. So I'd like to invite any other questions to come in on the Q&A. Excellent, all right. Well, if there are no other questions from the group, I'm happy to wrap us up a little bit early, give you guys, oh, I see there's a question. Oh, there's a good question for you from Charles. How large was last year's cohort?
Last year's cohort, well, it depends on how you count. We had around 17 students enrolled in the program, but we only graduated 12. And the reason we graduated 12 is because several of those students are taking more than 1 year to finish the program.
That's great. And I think that might, be something kind of worth highlighting here too, is that when you're looking at data science programs, very often it's kind of a boot camp model, or it's a programming school kind of model. I think going from, the fact that Willamette is a liberal arts school, these classes are highly interactive. They're inquiry based, they're taught in a cohort style setting, and we have faculty that really love to teach. So it is one of the differentiators for our program. And
yes, real professors with real PhDs and real experience, dedicated to their students. Who knew that was still a thing in this type of work?
it's a good thing. So yes, our program is real, you guys. So an opportunity for great. So one more question for you, Jameson. So how do you think a residential or in-person program is advantageous compared to the many online MSDS programs?
There are a couple of ways that it's advantageous. One is that you actually form a network with the folks that you're taking the classes with. And we know from kind of a lot of history in other graduate style programs that the networks and relationships that you form in grad school persist and are helpful in your career over the long term. There are a couple other reasons. One is that pedagogically, we know from research that in-person education is more effective at actually delivering on what we claim to be delivering on. So the statistics for online education, and in particular asynchronous online education, are pretty dismal. With completion rates in the range of 5 or 6% for many of the kind of large online versions of this sort of education, and much lower engagement and completion rates for the purely online versions of this kind of content. And then I would say the third reason is access to instructors. So our professors are there before class, they are there after class, they're meeting with students on a regular basis, helping to ensure that everyone is successful along the way. And that, frankly, is just a service that is very difficult to deliver in an online format. And Hillary is going to kill me if I don't mention it, but we also have an integrated career component in our program that generally isn't available for the online only programs. So you are actively meeting with industry professionals, shaking their actual hand, and presenting in front of actual industry professionals, right? So the level of exposure that you get in a program like this is hard to beat in an online context.
That's a good point. Thank you. It might still be pandemic elbow bumping for a little while. So we just had a question come in from chat. One of our participants says, I'm currently an undergraduate student with the goal of conducting research on wildlife. Do you think this program could be a good fit?
I do. I think that environmental science and data science applications in the natural sciences in general is a growing area in this region. So I mentioned that a colleague of mine does data science on salmon migration. So I'd be happy to put you in contact with that individual. They could probably give you some insight about what that career is like. I think the work is pretty cool. So he attaches sensors to seals, and then he tracks how those seals behave, because the seals are feeding on the salmon. And by understanding how those seals kind of move about the river mouths and elsewhere, they can understand how the salmon runs are likely to be affected during the fall and other times. So that is one application. The other two major applications of kind of involved in wildlife are forestry, which is huge here in the state. And there are many, many applications of data science to forestry. I was working with a student over the summer who was interested in using machine learning models to classify tree varieties in the region in order to map out kind of a historical territory of the Native Americans in this area. There are other ways that you can use these sorts of models to understand ecological change in the area. So those are options. And then of course, if you're interested in, I guess this question was about wildlife, but if you're interested in dead life, you can also look at computational biology, as a way to use data science skills to understand things like DNA replication, drug application, that sort of thing. We will also be having an elective this summer on natural science applications of data science. Which is going to kind of step through a variety of different applications, from physics to chemistry to biology to environmental science, taught by Jed Rembold, who is one of my favorite professors in the program.
That's great, thank you. Abigail, did that address your question? And that takes me to the end of the questions and chats that have come in. It does actually lead me to another observation, in light of what you just said, Jameson, which is that if you guys are local, we would love to invite you to come and sit in a class. If you wanted to come and, I know summer's a little ways out in terms of that one kind of science related class, but, we would love for you to come and join us. So look out for follow-up from me about how to do that. I'd like to thank Professor Jameson Watts for leading our discussion today. Thank you, Jameson. And thank you everyone for joining. Go ahead.
Thank you, Hillary, I appreciate it.
All right. Well, look out for follow-up, and we hope to see applications from everyone soon. All right, thank you.